Hello, everyone, and welcome to this BA Collab Hour webinar, CDR BeerLab, an easy-to-use device for the real-time monitoring of your beer making process. My name is Joe Damgard. I'm the Sales Activation Manager here at the Brewers Association. Before we get started for today, just a couple tips I wanted to go over with you. If you have any questions during the presentation, please use the Ask a Question feature at the bottom of your screen. You can use the chat to interact among yourselves, but please make sure if you have a question that you'd like answered, you add it there. You can also vote up other people's questions if you want to hear the answer to those. If you have any problems during the presentation today, the first thing to try would be a quick refresh. That usually fixes things. If that doesn't work for you, go ahead and add a message in the chat, and someone here at the Brewers Association will help you troubleshoot that the best we can. Reminder that this presentation is being recorded. It will be available at this very same link once we wrap up the presentation today. And the PowerPoint presentation slides for the presentation are available for download at the green button at the bottom of your screen. That's about all I have on my end. So I'm going to go ahead and hand it over to our presenter for today, Simone Belisai. He's CDR Food Lab Division Manager. Simone, why don't you go ahead and take us away?
Okay, thank you very much, Joe. So we can start the presentation. So in this presentation, I'm going to introduce you the CDR BeerLab. That is a system to run analysis on beer, wort, and water. Before to go ahead, I'd like to introduce a little bit who is CDR. CDR is a company that works mainly in 4 different sectors. We work in the telematics sector, where we produce automatic toll for the motorways or the highways in Italy. We have also a medical diagnostics division where we produce system for hematology and hemostasis. Our main sector is the food diagnostics with our CDR Food Lab division, in which we have systems for the quality control of food and beverage. We started a new sector actually in the pandemic time, where we produce sensors, probes for a specific food sector. Okay, can move ahead. Next, please. Okay, so no, the other. Okay, so CDR Food Lab is a system, is a range of chemical analysis systems, easy to use and versatile. The system is composed by the analyzer. As you can see, we have 2 versions, a big one and a small one. And we have also dedicated reagents. We produce both parts. So we produce the analyzer and we produce the reagents as well that are pre-filled in cuvettes. After this short presentation, just I think 30 minutes, we are going to show an example of analysis, changing the camera and showing how it is easy the using of this system. Next. Okay. Here we have, so as I told you, we work in the food and feed sector. We work in this case, we have the food lab. We work in the beverage sector, wine, beer, and water, and cider. And we have also a kombucha. We work also in the kombucha sector. And we work, of course, in the oils and fats sector with different analyzers. Food lab, an analyzer dedicated to the olive oil, the oxy tester, and another one dedicated to the palm oil, the CDR palm oil test. Okay, next. Okay, so as you see, the system, now we are talking specifically about the CDR BeerLab, is composed by the analyzer, a pipette to take the sample, and the reagents. So with these 3 parts, you are able to analyze practically and to perform the entire chemical quality control in your beer making process. Next. And as I told you, we are able to analyze water, we are able to analyze wort, and we are able to analyze beer. So practically, we can cover the entire beer making process. We are going to see, for example, an analysis of alcohol, and let's see if we have time. For sure, we are going to see an analysis of water and maybe an analysis of fan, mixed up all together. Okay. Next. Okay, here we have the instruments features. So as you see, now we are talking about the big analyzer. We have an incubation part, we have a reading part. Of course, all our systems are based on photometrical technology, and we have no maintenance to do. We use as a reading part LEDs as a wavelength sources, so we don't have any problems in the reading part. We can keep the analyzer switched on all day long without any problems. And for example, it's not the case of the beer sector, but we have analyzers that work 24 hours a day on production lines, for example. We don't need any calibration, and you can work. Now I'm talking about the big analyzer. You can work in two different ways. You can analyze different samples at the same time, so you can perform up to 16 analyses at the same time, or you can work also in another way. You can analyze different parameters at the same time. Of course, in this case, you need to manage different cuvettes on the analyzer. We give a 3 years warranty, so it means that the analyzer, the system, is very strong, and you have also all the methods on the touch screen of the analyzer, so you can follow step by step what you have to do. We are going to see after these methods and how are displayed on the screen. Next. Okay, here we have the reagents features. As I told you, CDR produces both parts, analyzer and reagents. We produce reagents in pre-filled cuvettes. So the reagents comes in packages of 10 tests. So inside you find 10 cuvettes, 10 pre-filled cuvettes ready to use and already calibrated. Okay, so the analysis consists to take the sample, put the sample into the cuvette, and wait an incubation time that normally is between 10 seconds to 10 minutes. Okay. About the shelf life of the reagents, normally we have 1 year of shelf life. Next. Okay, here you have the most important advantages of the CDR BeerLab compared to the standard reference method. So we work to reduce the time of the test. So normally you have quick analysis. You have a very easy handling, and we are going to see how easy it is using of the equipment. As I told you, you have the reagents ready to use, and you don't need any laboratory. You need just a desk, you need the analyzer, the few reagents, and the pipette. So you can set up your quality control wherever you want in your brewery. You have no maintenance because I told you the system is very strong. The reagents come already calibrated, so you have to do just the analysis. Practically, in the end, everyone can run analysis with this system. Okay, here we have the analysis, the panel of the test we can do. As you can see, we can run fermentable sugars, carbohydrates, alcohol by volume to manage the alcohol fermentation. We can run zinc, in the water, again for the alcohol fermentation. We can run color, we can manage the IBU, we can manage the meshing through the starch analysis or the pH. We can check also the vitality of the yeasts and the SO2, for example, or also the VDK. So we can check also the diacetyl rest of the beer. Another important analysis is the FAN, the free amino nitrogen, to check the beer stability and the yeast nutrition. Here you have also all the analysis we can do on water: calcium, magnesium, potassium, bicarbonate, alkalinity, and zinc. So as you can see, you have a wide panel of tests you can use in your brewery to check your beer making process. Okay, here you have a table. I don't know if you are able to see properly. You have two tables for beer and wort and water with the measuring range. Just an observation about the alcohol. For example, you can cover all the alcohol results from the no alcoholic beers to the highest alcoholic beers without any problems. We have different ranges that can be used. Okay, just a few words about the sample treatment. As you know, we are talking about beer, so we have the CO2. We have to remove it. One of the advantage of the system is that we maybe I forgot to tell you is that we use micro quantity of sample. Okay, so we need just with 1 milliliter of beer, we can run you can run all the analysis you want. So we are able to degas the beer very easily. So here, as you can see, and we will show you with an easy ultrasonic bath, you can in 2 minutes you can degas completely your beer, and after you can collect the sample and run the analysis. About the wort analysis, the wort, of course, has turbidity, so you have to remove this turbidity. Again, here with a very small centrifuge, you can in a few minutes, here in 2 minutes, we can clarify the wort and run the analysis. Okay, so with these other two accessories that you can put along your BeerLab, you can treat easily your samples. Next. Okay, here you have a table of comparison between BeerLab, the big analyzer, and the Junior. And okay, in the BeerLab you have all the analysis inside. You have a printer. You can carry out, as we've seen before, 16 analysis at the same time of the same parameter, or you can run different analysis at the same time. With the Junior can be tailored of your choice, so you can select the analysis you need. You don't have the printer, but of course, in both cases, you can export the results to your computer without any problems. And of course, here you can carry out only 3 analyses of the same parameter. Okay, so you can't perform different analysis at the same time. You can do only a session of the same parameter. So what about a few words about the beer making process and how you can introduce the analyzer into the beer making process? So you have, we can split the beer making process in 4 parts: the mashing, the boiling and bittering, the fermentation, and the conditioning. So we can introduce the BeerLab in all these 4 parts of the beer making process. So let's start with the mashing. And here easily you can manage the pH. getting the right pH for the saccharification of your wort. You can manage the color, the extraction and the evolution of the color. You can manage the sugars, so you can, if you want, studying the sugar evolution, and you can get, of course, the potential alcohol that you will have in your future beer. And if you want, also, you can, and we have a specific case study that talks about that. You can, studying the evolution of the fermentable sugars, reduce your meshing. And anyway, we will talk a little bit about that before, after. Also, the starch test to detect the endpoint of your meshing, and in order to have the complete conversion of your starch in the fermentable sugars, glucose, fructose, maltose, and maltotriose. Next. Here, a focus on the sugar. We detect the fermentable sugars, glucose, fructose, maltose, and maltotriose. We have also the possibility to detect all the carbohydrates. So, by the difference, we are able to detect the not fermentable sugars that are the dextrins in your finished beer, for example. Okay, so you have the possibility to check as best as you can the end of the alcohol fermentation, for example, as we do normally in wine. Okay, the IBU, in this case, we use practically an optimized reference method. We have a small scale reference method with the BeerLab, so you can easily perform directly at every step your IBU, in order, if you want to follow the evolution again of the bitterness along your beer making process. And of course, with this analysis, you are able to optimize your recipe. And we have again another interesting case study. Of course, we can't talk about all this in this presentation, but you are able to download our collection of articles if you go to our website. Next. Okay, here we have a focus on the free amino nitrogen analysis that actually is a very, very important test in the quality control of the beer, because, as you know, you need to have high free amino nitrogen values before the fermentation, because the free amino nitrogen is the nutrition for your yeasts. So it's better to have a high free amino nitrogen level before to start the fermentation. At the same time, in your finished beer, it's very important to have a low value, a very low value, as low as possible, of this free amino nitrogen, because, of course, the free amino nitrogen could, in your finished beer, could introduce off flavors in your beer. So you, with this analysis, you can find the best compromise between the high free amino nitrogen level before the fermentation and the low free amino nitrogen level in your finished beer. So we are talking about to analyze the amino nitrogen in the wort before the fermentation and in the finished beer. You can do it in the same way with the BeerLab. Next. Okay, here a few words about the VDKs, or the diacetyl rest that we can call it. We have a specific kit about the VDK. Of course, we need the distillation. So to improve the distillation and to let the distillation be easy, we improve this VDK's distillation kit that is made by a glassware kit that you can easily set up in your on a desk, and along with a heating mantle. Okay, so with this apparatus, easily in 20 minutes, 25 minutes, you can distill your beer, and after you can run the VDK with the BeerLab. Okay, the bottling and the second fermentation. So if you perform a second fermentation, you need to check the sugars that you have to add in the bottle. And again, here the residual fermentable sugar analysis is a powerful tool to avoid unpleasant problems of overgassing of the beer. So with this analysis, you are able to check the fermentable sugars at the end of your alcohol fermentation, and you can add your sugars depending on the level of the fermentable sugar, residual fermentable sugars you have in your beer. All this in order to avoid overgassing problems into the bottle. Okay. Of course, at the end, you can run an alcohol, and you can run also a total SO2 analysis that are both important tests. The SO2, another important analysis. The SO2 is produced during the fermentation by yeasts. There is a legal limit. So here again, easily in 2 minutes, you can have the results. Of course, you have to degas the sample. You degas the sample, and after you can run the analysis. And again, here we are using the EBC method, or that is equivalent to the American method practically. Okay, here what we have, for example, this is another case study we had we made in collaboration with our UK distributor, where we demonstrate the accuracy of the BeerLab on non-alcoholic beers or low alcohol beers. Okay. As you see, we have two measuring range. The lowest one between 0.001 to 0.1, so you can detect absolutely if you have a little residual of alcohol in your beer. Or we have also another range a little bit higher, between 0.1 and 2. As you can see here, you have the labels. And you have the results of BeerLab along with the results of a certified laboratory in UK that is Camden BRI. And as you can see, you have the CDR BeerLab results are very close to those ones of the certified lab. You know that, of course, doing comparison with the label is not so accurate. So we have decided to do this study to compare the BeerLab with the Camden BRI, the certified laboratory. Okay, the water analysis. Again, here the water is very important and is different from everywhere, and so this is the reason why it's very important to check it if you are not able to reproduce it in the proper way. So again, here you are able to detect practically the most important parameters that can affect the taste of your finished beer. In the next slide, for example, we detect calcium, magnesium, that is practically the hardness of the water. We detect the alkalinity, sulfates, chlorides, bicarbonates, and zinc. So zinc, as we've seen before, important for the alcohol fermentation. So again, here you have a wide range of parameters to check your the water you use. Okay, here you have a few references. We have a lot of references worldwide. So I don't know if you know some of these names. I put all together UK breweries, Italian breweries, for example, Brewfist, that is pretty famous, or Birra Baladen, that is another important brewery in Italy. We have also big breweries like corporates like Heineken. So as you see, we have a wide range of different kind of breweries, okay, that are using our system. Next. Okay, a few publications about the BeerLab. Here I put together an assessment about the BeerLab analyzer, and here you find 3 different case studies. I think maybe is not the last version I sent you, Joe. Anyway, we can move ahead, no problem. Okay, so we find about the assessment of the CDR BeerLab. Here, practically, we have compared the CDR BeerLab with, as we've seen before, the Camden BRI, the certified laboratory, in order to assess the accuracy of the BeerLab compared to the reference method about alcohol by volume, color, pH, bitterness, vitality, and VDKs. Okay, so the next slide we'll see. Okay, here is not. Okay, we can jump on the other. Joe, I think is not the last version I sent to you. Anyway, okay, here because I had to cut a little bit the presentation in order to fit the time. Sorry about that. Okay, here we have, for example, in these graphs, you can see the accuracy of the CDR BeerLab compared to the reference method. The R squared, this number, represents the accuracy of the CDR BeerLab. So if you have a close R squared to 1, it means that you have the best accuracy. So as you can see, we have practically all R square of 0.98, 0.99, or just in the case of the vitality, that is a very particular test, we have 0.90. Consider that in the medical diagnostics, we have a good R square. The good R square is considered more or less around 0.92 or 93. So here we have a lot more of this. Okay. Okay. Next. Okay, here you have some extracts that that tells you that how is accurate and exact the BeerLab. Okay, here we have some case studies. So Bed & Co. Okay, next. Okay, here is written that having, for example, an in-house quality control has proven essential in the pursuit of a listing with the national retailers. So here you have a quality control very important for to have a good beer, let's say. Next. Okay, here we have another case study that practically here we are in the south of UK, And here we can demonstrate that if you are able to study your meshing phase, you are able to reduce the meshing time, saving money. Of course, you can download this case study that is made in collaboration with QCL. Next. Again, okay, here I think, Joe, we can move ahead because yeah, because of course we lose time to introduce and to present the analysis. So we can go a little bit fast on this, and I think anyway, all these case studies that you have in this presentation, you can find them in our website. So we have, for example, a collection of articles that you can download, and you have all these articles together. And with these articles, practically we demonstrate how it is important to have a tool like the BeerLab to check the beer making process. Okay, I think now we can switch the camera because I want to show the system. I want to show you the system. So we'll switch the camera, and just a second. Okay. Okay, I'm looking now at the chat, and yes, I recognize a fan of Back to the Future that recognizes the flux capacitor on the screen. Okay, so let's start run some analysis. So here you have the system. Okay, so you have the big one, okay, and the small one, the little brother. Okay, so we can. Okay, the first thing we have to do is to degas the beer, and here we can take a bottle of beer, and just a few beer like this is more than enough to run all the analysis you want. Here we have an ultrasonic bath, and we can power it up, and easily we have half the CO2. So after 2 minutes, you can easily collect your sample. Okay. So after this step, of course, we have now we are talking about the first analysis I want to show you is the alcohol. Okay. Okay. So here we are selecting the analysis. So you can press on analysis. You can press on beer, and we can here we have the list of all the parameters. So we select alcohol by volume, and here you have different ranges. So we select this one, 1 to 10, normal beer, and we start the analysis. So on the screen you have the method, so you can read the method on the screen. Okay, so on the screen is written add 100 microliters of R1A, and after you have to add 100 microliters of diluted sample. So here we have already just to have more time. We have already prepared the dilution. So in the kit of the alcohol, you have a vial like this. So you have to take after the degassing, you have to take the 100 microliters. You put these 100 microliters in, and you have your diluted sample. So after that, we can start running the analysis. Okay. So we take the pipette. We select 100 microliters. Okay, and in the package, as I told you before, we have packages of 10 tests. So inside the package, you find 10 profiled cuvettes, and in this case, 2 bottles of reagents to perform the 10 tests. Okay. So we have 100 microliters of R1A, as it is written on the screen. Here we have just to wipe the tip like this. This is the most difficult operation of the analysis. We open the cuvette and we put the tip into the liquid, and we press up and down, all the way down, to release all the reagent into the cuvette. After this, we can have to add the diluted sample. So we have already prepared the diluted sample. So in the same way, the same 100 microliters, we collect the sample. Again, here we wipe tip like this, and that's it. We put into the liquid the tip, and we release the sample inside the cuvettes. This is the most difficult operation of the analysis. So now we shake by inversion, and we start the timer. Now we have just to wait 1 minute, so you can do your stuff of in your brewery. So as you can see here, we have the incubation part. Okay, this is the reading part. So after this first step, we are going to take this cuvette and put the cuvette into the right reading cell that will be indicated by a blue light. We're going to see that after, and we can move ahead with the analysis. In the meantime, if you want, you can press here, you can continue, and you can select another test. For example, after this, we are going to do the magnesium. So we select water, and we select the magnesium analysis. So we get in the magnesium analysis now. Okay. So from this part of the screen, as you can see, okay, you have the alert now because the first incubation time of the alcohol is finished. So we press here, and you can see that the alcohol by volume is ready to go ahead. So we press on alcohol by volume, and we go ahead. You have here sample 1. Of course, you can change the name of the sample if you like. And now we have just to insert the test tube into the reading cell. We shake a little bit by inversion before, and we press to do the reading. As you see, you can press on sample 2. So as I told you, we can do a session of analysis. Now we have to do just 1 test, so we press stop. And this is the screen of the second part of the analysis. Now you have to add 50 microliters of R2, shake, and start the timer. So we do the same operation. So as you can see, for all the analysis, you have to use a single pipette. Here we change the volume of the sample. To 50 of the sample, sorry, of the reagent. We take back the cuvette into the incubation part, and here we take 50 microliters, and we add the 50 microliters into the cuvette. We shape by version, and we press, and we start the timer. Okay. Practically, the analysis is finished. Now we have just to wait 10 minutes. We have to read back the cuvette into the reading cell, and we will have the result. So, in the meantime, as I told you before, we can do an analysis of the water. We have two kinds of water here, and we can analyze them. We have already prepared the cuvettes of magnesium here, so we can go back to magnesium, and here you have on the screen the magnesium analysis. On the screen is written that in this case we have just to read the cuvette. So we take the first cuvette, cuvette 1, and we read it. We select sample 1, and we read the blank, the starting point of the reaction. As you can see here, sample 2, and we move ahead with the sample 2. So cuvette 2, we select sample 2, and we read it. So now we are doing two analyses of water, of magnesium in water. At the end of the session, we press stop. On the screen now, says you have to add 20 microliters of sample. So we change the volume of the pipette, and we collect the sample. The first one. Here, same story. We have to wipe the tip, and we open the cuvette. We put the tip, into the liquid, and we press a few times all the way down. That's it. Practically, what we have here, we have a changing in color, and this changing in color is correlated with the concentration of the calcium, of the magnesium. So we put the cuvette into the reading cell, and we read it. Sample 2, because of course we have read 2 blanks, 2 cuvettes, so the analyzer is waiting for the second sample, and we are going to collect the second sample, this one. Same story, wiping off the tip, and we open the cuvette, and we do the same. We put the tip into the liquid, and we press all the way down. We shake it in order to homogenize the cuvette, and we read it. And here we have the results printed on the paper or displayed on the screen. So all this while we are waiting for the results of alcohol. So now we can jump back on the alcohol analysis, and we can see that we have 5 minutes to wait. So I think in the meantime, we can, if there are, we can answer some questions.
Yeah, Simone, it looks like we do have a few questions for you. Let me just get right in here. First one, people are curious as to where to best find this system and where to find out more information about cost and whatnot with the systems that you offer.
Yeah, of course. You can refer to our website. So you have written on the presentation, cdr.beerlab.com. So on our website, of course, in the section distributors, you can find the US distributor about BeerLab. Okay, so there you can fill. You find a form. You can fill the form, and we will forward to our distributor, from whom you can receive a quotation, or you can have all the answers about the system.
Excellent. Another question, as far as like the display on the units, is it possible to change the displays to English?
Of course. Yeah, of course. We have all the languages. I can show you the changing here on the settings. Of course, maybe there are some Spanish speaking people. So here on language, you can find we have English American, Spanish, French, German, also Poland, and we have other languages. So automatically you will switch to methods in your own language. Okay, no problem at all. We sell all over the world, so we don't have any problem about the languages.
Excellent. And the last question as of right now from Marcus, he wants to know if there are detailed instructions available for us non-chemists out in the audience.
Yeah, as you've seen, you don't need to be a chemist. You have just to, you have to understand how you can use a pipette. And also about this, we have, for the most important parameters about the BeerLab, we have also tutorial videos. So you can look at the video, you can watch the video and see the perfect handling that, as you've seen, is very, very easy. Anyway, with this tutorial, you can study them, and you can replace the same handling on your analyzer. And of course, we have here we can look at the method. For example, these are our methods. So these methods are not for chemists. So as you can see here, you have add 50 microliters of R2. Of course, the R2 is written on the bottle. So in the kit, as I told you, you find 10 cuvettes and 1 or 2 bottles, depending on the kind of analysis, that are the reagents to run the 10 tests. Okay, so here you have the method, or for example, you have the help function here. So you can press on the help function, and you have the method with the help of the pictures. So you can scroll and you can read, in this case, step by step, while you are running the analysis, you can read the method, okay? So it's absolutely for no chemists, okay? And of course, if you want, we have the PDF versions of this. So if you want to read them on the normal PDF, you can do it, or on a paper. You can do it without any problems. Anyway, here you have the possibility, for example, to If you want, you can check the method from the beginning. Here you have the possibility to scroll the entire method, while, here you see the entire method, or during your analysis, you have the method step by step, okay? So you can do what you want, and as you can see, the method is for no-skilled people. So if you are not a chemist, don't worry, you can use it without, you can use the BeerLab without any problem.
Excellent. That's very helpful. We don't have any more questions at the moment, but we do have some time left. So if you have questions, please do add them there. Simone, do you have any other tips or tricks that you'd like to share with the crowd?
Here we have finished the analysis, so we can finish it up. Okay, so we are again on the alcohol screen. So the after the 10 minutes, where you can talk, you can work, you can do what you want. We go ahead and we take the cuvette, we shake a little bit before the reading. We put the cuvette into the reading cell and we press. And we have the result. As you can see, we have 5.3. This is the bottle. I don't remember well. Where is the no? What was the?
Era 8.
Here we have. Okay. On the label, okay, consider that the label is not sometimes is not perfect. Anyway, we have 5.4. Okay. So this is the BeerLab. So here you have seen the alcohol, the free amino nitrogen practically is absolutely the same without the dilution. So it's even easier. SO2, you have to wait 1 minute with only one reagent. Anyway, the handling is the same for all the analysis. So you can imagine that to run all this analysis, if you think about the normal laboratory, you have to think about a distillation apparatus for the alcohol. You have to, you need a photometer with reagents that you have to calibrate. So you need a laboratory. With the BeerLab, in this space, now we have also the junior, so we have a unit more. We can have the BeerLab, an ultrasonic bath, and a centrifuge, and you can run all the chemical analysis you need in your brewery. Okay. So if you have questions, I don't know.
We don't have any more questions at the moment. If there's anything else you'd like to share, but before we go to that, I just want to thank CDR BeerLab and Simone for the great information today. Seems like a very powerful device, or a couple of devices that you're offering there. Simone, anything else that you'd like to add?
So of course we have, if you, as I told you before, if you need information, you can address to our website that Joe has posted on into the chat. So if you need information, if you have questions, you can. We are here to answer you.
We just did have one more question come in from Drew. He asks, is there a data exchange function with other systems? Can you export the data? For example, a water analysis, which goes directly into a recipe for needed water salts.
Yeah, of course. As I told you, we have the possibility to check the results, and to connecting the analyzer to the computer, you can export all the results you want. You can filter the results. You can, in this case, the analyzer produces a CSV file that you can treat as you like.
Excellent. Thank you for that. That is the last question as of the moment. Another quick reminder that the slides from the presentation are available at the button at the bottom of your screen. You can rewatch the presentation after the fact at this very same link. That's about it. Another big thank you for CDR BeerLab and Simone. Great presentation today. Any parting tips?
Thank you very much. Thank you very much, guys.
Thanks, everybody.
If you don't have any other question, I can again. We are here if you can write on our website, and we will be happy to answer you.
Excellent. Thank you, Simone. Thanks, everybody. Have a great day.
Thank you. Thank you, everybody. Bye-bye.